Good morning, good evening, wherever you are. My name is Mark Borstein. I'm the CTO of Tremolo Security, co-author of Kubernetes and Enterprise Guide, third edition. I don't know if Scott's going to be joining us today. His day job might be getting in the way, and that happens sometimes. But we are going to be wrapping up our journey into Istio. So the last couple of casts, we started off with deploying Istio. Scott gave us a really great overview of the way the different Istio objects work together and how you get those to kind of come together, build a service mesh. Um, and then we rolled out Kiali and the testing app. The last week, we went ahead and got Kiali integrated with Open Unison, so we could talk about how monoliths work inside of Istio. And it's really important to distinguish between the way you deploy a monolith and the way you deploy a microservice. Um, in the book, in chapter 17, where we start talking about deploying applications inside of Istio. Um, hey, there's no need to fear. Boris is here. Always a pleasure to see you, my friend. Um, so we start off the chapter talking a bit about the differences between microservices and monoliths from a development perspective. And this is really important because um, microservices are really great when used properly, but they shouldn't always be your default. Like it shouldn't always be the first thing you go to. I start off with an anecdote from when I first started working professionally, and I was all gung ho about breaking up some applications that I was working on into what at the time was called three-tier architecture. So this predates the idea of micro services, but you had a presentation layer, a business layer, and a data layer. And where I was working, that business layer and that data layer were very commingled. We were using a lot of stored procedures. All of the business logic was in those stored procedures. And so you really only had two layers. You had the presentation layer and the data layer. There was no distinct business layer. And so I was pushing this where I was. And what the my bosses were saying to me was like, look, Mark, we get what you're saying from an architectural distinction, but what are we getting at this? Like, why would we refactor this code, spend this time, spend this money? The code works great. It scales just fine. What are we getting out of it? Besides architectural cleanliness. And I find the same conversation happens a lot with microservices, where we start off with, hey, we're going to microservice everything. And it's like, why? Like what's the benefit of having microservices in this case? Um, so it's important to understand why you want microservices if that's in fact what you want. What's very different about this part of the book is we have spent 16 and a half chapters building out infrastructure. This is the first time we're building something that's an application. Right? Like we did a little bit of application back in the authentication chapter just to show off how authentication works. But this is really the first time we're talking about how applications are built, how APIs are built, how they're constructed. So if you're watching this and you're reading the book from an application development perspective, understand that we got through 16 and a half chapters before we really started talking about applications for a reason. And it's because there's a lot of work that goes into managing the infrastructure that supports all of our applications and our APIs. So it's really important to realize that when you're coming from the application developer world the way I did. So why don't we dive into it? We got a lot to cover and a lot of really complex topics to cover. So last time we wrapped up by getting Kiali integrated with Open Unison. So that was on page 534. And I'm going to go ahead and no, there we go. So let's go ahead and add this to my screen. And so come over here. We'll go ahead and log in. Where were we last time? We've got Open Unison. It's all integrated with our Kiali. everything just kind of works, right? So that's where we ended things. We've got the dashboard. Um, Thanks, Mom. Nope, I'm eating just fine. Thank you. I'm eating enough. Yep. We got the dashboard, all that stuff's working great. Um, Now let's actually start diving into our application and building out some microservices. So we're going to integrate what we've learned the last couple of weeks with our microservice. We're going to authenticate the service. We're going to provide authorization, and we're going to get into OPA for externalizing authorizations. And then finally, we're going to get into how services talk to each other in the mesh and how that identity works. So we're going to deploy a really simple Hello World application. This is a just simple Python script. There's not really a lot going on here. So where am I? I am in the main chapters. I'm going to go to chapter 17. I am on page 536. So I'm going to go into the Hello World. And I'm going to deploy Hello World. Not a lot going on here. We got a config map. We've got a deployment. Not really a ton going on here. I should actually bring this down so that way we can look at it. Got my scratch pad going here too. Why don't I make this a little bit bigger? So if we go to chapter 17, make that a bit bigger, and we're going to go to Hello World. So here's hello world.yaml. And what we have here is we got a config map that just has our code. Not a whole heck of a lot going on here. We've got a health check. We got something that says who we are. We got something that spits out headers. So not a lot of business logic going on here. Simple deployment. Got a service. And then if you remember going back to our previous, actually it's soda water boars, so no calories this live stream. We've got a service that a gateway that is our, kind of like our ingress saying, hey, have access to this server, and then our virtual service connecting it to our pod. So if we come back here, let's go ahead and just curl this. And right now we don't have anything from a we don't have anything from a authorization or anything standpoint, so it just worked, right? Like there's not a lot going on. So first, let's go ahead and add authentication. So the way microservices work, when you do your authentication, microservices are not web applications, right? They don't intercept the request and redirect you over to a browser, get you to log in, and then come back, right? They're expecting a token for the most part. So if we're going to add authentication, we need something to authenticate to. Yep, everything's running on kind. This is the make a good point to bring up here. This is the lab from last week. So everything up to page 536 has already been rolled out. So we've already rolled out our kind cluster. We've deployed Istio. We've deployed Open Unison and Kiali, and everything's already been integrated. So that's a great point for us to point out. So we need something to authenticate against. Now we have Open Unison running in this cluster. So we're going to go back to our Chapter 6 lab and deploy our identity provider that we used for API services. So we're going to go to, where am I? I'm going to go up to Chapter 6. And where am I going? I'm going into Chapter 6, Pipelines. And I'm going to run the Helm charts. Whoops. I'm going to go into Pipelines. All right. And then I'm going to go ahead and run this Helm chart from the book. Yep, that looks good. All right, so we deployed. If we do a kube control get applications and open Unison. So we've deployed this application called Token API. It's only been around for 8 seconds. We'll edit application, Token API, open Unison. So this is an open Unison application. We're not going to dive too deeply into it other than it's a way to quickly be able to get a token based on a username and password, right? So that's not really what you want to do in real life. But in this demo, we're just going to keep things simple. In real life, you're going to want to authenticate your services with some kind of API identity for your caller. So if you're going service to service, maybe it's the token for your pod. Maybe it's your if you've got a VM in AWS, maybe it's the identity from there. But the idea is you don't want to have a static key like this. But to keep things simple, that's what we're going to do. So we've got our Open Unison updated. So now we have a identity provider. And so the next thing we're going to do is we're going to deploy authentication for our Hello World service. So let's go ahead and check 17. And then I want to go to authentication. So deploy auth. So what we're doing here is we did a few different things. The first thing we did was we created. Hey, bonjour, Kafka. Welcome, my friend. We created a few different objects. So the first object we created was this JWKS config map certs. So if you look in the scripts, we deployed cert manager with our cluster and a local identity provider. So you need Istio to trust that certificate, that CA from Cert Manager, so I can talk to Open Unison to validate tokens. And so that's what we did here, where we actually updated Istio to trust it. So if we look at, let's go ahead and look at this code. So if we go to authentication, deploy auth. So we created a new certificate map. We patched our deployment to Istio JSON, which adds these extra certificates that we are trusting into IstioD. IstioD isn't using the Kubernetes API to pull these certs in. It'd be nice if they did, but you got to patch that. And then finally, we went ahead and restarted Istio. So at that point, we now have a working Istio that can validate against Open Unison. And then in our service auth, we went ahead and updated it a little bit, where we said, okay, we're going to request authentication, right, against our identity provider. But remember, you have to have both an authentication and an authorization policy. If you don't have an authorization policy, you will be in a situation where you can say, you'll be in a situation where you say, if no token is provided, that's okay. If a bad token is provided, that's not okay. And that's not what you want. You always want to have a token. So that's why you go with your authorization policy. And the colors. Kat introduced me to the theme that she uses, which is all purple. I don't love purple as much, but I do love red for, tremolo Trimble over here, right? So this is the only theme I found that had mostly red colors, and I like it. It's easy on my eyes. So our authorization policy says, hey, we're going to allow everything, all identities, but you have to have an identity, right? So that's what that script ran. So if we come back here, let's go back over here. So our authorization policy is deployed. And so we reviewed what's going on in there. So now let's go ahead and give it a try. So if we do the same command we did before, which was a curl command, eventually, curl, right? Access is denied, right? I'll do a, do a -V so you can see the whole thing. That's because we don't have a token in there anymore, right? So that's why that failed. So let's go ahead and get a token. So I'm going to grab this. And let's come back here. And I've actually got a scratch pad that I'm using. So you can see here I've been going through the exercises, but I want you to see what's going on here. So grab this. I'm going to change my host name. Nope, I got to change my host name here too. All right, so let's grab this whole thing, drop it in, clear. So what's going on here? So it worked, right? Why did it work? Well, the first thing we did was we called this command here. I'll pull this out. So we did a curl with our mmosley username and password to the token user, and this got us a token. Once we had the token, we're then able to embed it directly into our curl command. So we're now authenticating to our API using a valid token that was generated by OpenUnison. So now we've got authentication on our Hello World service, but we don't have any authorization, right? So that's kind of that next step is how do we go ahead and figure out how to authorize who can access the service? So I'm on, where am I? I'm on page 540. And we've got authentication. So first thing we're going to do is we're going to delete our existing policies. So this is at the bottom. So we deleted our existing Hello World policies. And so now we don't need a JWT again. So let's make sure that that's still the case. Right, so not quite yet. Clear. So we're going to go ahead and just put on a watch until, oh, no. So, nope. Curl. Okay, so we're able to access our service without any more authentication, right? We deleted our authorization policy. We also deleted our, we deleted the authorization policy. So we don't have a token anymore. And so it's letting us through. Now, funny, so this will kind of show you what I was talking about before, where if we add a bogus authorization token, see, that should fail. Okay, so it didn't actually like that at all either. But you still got an unauthorized, right? Because it was a bogus token, even though the authorization policy is gone. So by not having that authorization policy, we can access the service without a token. But if the service does have a token, that token's expired or it's not valid, it'll fail. So that's what I mean, where you have to have both the authentication and the authorization for Istio. All right, so we're going to deploy the below policy. So we've got a new policy here, and I'm going to just do this. WD cat. Nope. WD. Yeah. Clear cat. Okay. So this is a new policy that we're going to deploy. And here we're saying we're going to authorize the user based on a group. So this is a very simple, very common static authorization process. So instead of saying, hey, we're going to let anybody with a JWT authenticate, this time we're saying we're only going to let users in the group 2 authenticate into our service. So let's go ahead and could control create F. Nope. Control create F. So it's on page 541. So created the service. Now we're going to do the same authentication we did before, but with a user that does not have access. So if I come here, go to the big authentication command I did. Right? So, no, that's, clear. Make my life easier. So that was the command with M Mosley start 1, 2, 3. Now we're going to do this a little bit differently, where this time we're going to run the same command, but we're going to do J Jackson. Now J Jackson, you can see here we're authenticating as J Jackson to get our token. Now J Jackson isn't a member of group 2, and so they're not able to access our service. So we have now managed to authorize our service, not just authenticate it. So that's that's kind of being able to do a static authorization inside of Open Unison, or excuse me, inside of Istio. So the next question is, all right, we've authenticated, and when we call call an API, how does the API know who we are? Right? Like we know Istio knows who we are. How does the API know who we are? So we're going to call a slightly different service here. We're going to call, nope, I don't actually want to go to that. Thank you. So let me pull this up. So this is on page 542. And I'm going to tweak this again. So this is very similar. 53. Except instead of calling the previous function, which was to just see what's going on, just to run a service, a hello world. Valid numeric literal. What I break? Let's see here. Authorization, bearer, insecure user. Yeah, let's see, that should do it. No. Invalid. Column 5. What am I missing here? Oh, I know why. Oops. I actually put this in the I found a couple of issues, and this is one of them. Yeah. I've actually posted um, an errata for this chapter. A couple of these examples actually don't work. And so I fixed them, and they're now in the GitHub repo. But what we can see here is, so this service just echoes back the headers as our service sees it. And what we can see, this is the important one, this user info. This user info header is the portion of the JWT that includes, oh, is that why I'm not seeing everything? That's why I'm not seeing everything on the screen. My apologies. So this includes everything from the JWT except the actual signature. So if I do echo into base64-D, and then JQ-R, there we go. So this is what our JWT looks like without the signature. These are called claims, and the issuer, excuse me, the issuer. Where did the token come from? The audience. Who's it meant for? When does it expire? JTI is a unique identifier for the token. When it was instantiated, not before, another timestamp. Who is the user? Sub, name, what's the user's name? What groups is the user a member of? Preferred username and email, right? Like, so this is pretty easy to take a look at. But what's important here is there's no signature. So your service can't take this and go hand it to another service, say, hey, I'm really Matt Mosley. And that's security. And we're going to get into how you talk to other services as the user in a moment or in a little bit. So that's how your API knows who the user is you can pull that user info, base64 decode it, and now you have all of the attributes. And so we kind of go through that. And so now that we know how to determine who the user is, we've got our code that kind of shows that off. And we looked at that here. Service auth. Nope. What was service auth? Where deploy auth? Authentication. Oh, hello world. Here we go. So if we go to the Hello World app, we've got this service in here called Who Am I? So this is the service here. Yeah, it's Python. And we're pulling that just like we did in the Bash terminal. Same thing, but in Python. We're getting the header user info. We're base64 decoding it. We're parsing it from JSON, and now we're able to work with it. So let's do the same thing, but this time we're going to hit Who Am I? I could just do Who Am I? And there we go. So I'm going to go ahead and run this again. So this time our API is now returning who the user is. So that's how your APIs know who the user is. So we know how Istio knows who you are. We know how Istio authorizes you. We know how your API knows who you are. So now let's go ahead and see, if you're a security person, you might be saying, whoa, 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 headers are super insecure. How can I trust that information? Why am I, as an API, I'm not validating anything, right? Like I didn't do any steps in here to validate the information. I'm just blindly trusting it, right? So how do I, as an API, know I can trust the information that's coming out of that header? Like what stops me from, say, logging in to just go ahead and put those headers in. Well, Istio takes that care of that for you. Because you're part of the service mesh, one, if you try to overwrite those headers, and we're going to show off trying to do that in a second, it won't work. Two, if you try to contact it directly outside of the service mesh, you're not going to be able to get to it. So it's the service mesh that's protecting your API and making sure that you're not able to hit it sideways, come at it from a sideways attack. So let's kind of show off what that looks like. So I'm on page 544. And the first thing we're going to do is we are going to try to kind of get into the shell and try and we're first going to try and access the pod directly, shell in, and try and hit the API. So if we do clear, kube control, get pods, and Istio hello world. So kube control exec. TI and Istio hello world bash. Okay. So I'm in my container. Now this is the one exception. I'm local, right? So I'm going to go ahead. Yeah. So I'm going to come back over here to my scratch pad. Now, something to just be mindful of with the copy and paste doesn't always work perfectly. There we go. So I've created a user info environment variable somewhere in there. There it goes, user info. So I've created a base64 encoded environment variable of my claims. And then I'm going to run a curl command. So what we're doing here is we're calling our microservice locally, but we're injecting the header. And this is actually going to work. No, it's not. Why didn't that work? Oh, I know why. I copy and pasted too much. All right, that worked. All right, let's do that again. So this way, we're actually able to inject the user info because we're on the pod itself, right? We're too low in the mesh for the mesh to actually do anything. So here we're able to actually inject that information, which is an important security point. We've talked about, the security of pods. You want to make sure you can't exec in, or if you can exec in, maybe there's only certain times you can exec in. Maybe there are only certain commands you can run. But if I'm execed into the pod and I don't have some kind of additional runtime security in place, this could potentially be a attack vector. So we've just bypassed all the security of Istio. However, let's try and create a new pod that's not in the mesh. So let's say we're in like a multi-tenant cluster and we want to try and hit a service that's running somewhere else in the cluster and try and bypass the mesh. So that's the next thing we're going to do. So now this is one of the things I talked about. I had to publish an errata on this chapter. This is actually this done the command at the bottom of page 544 does not work. So we're going to let me pull up the errata here. It's down here somewhere. Great, here we go. So chapter 17, page 544. So what this command's going to do is this is going to fire up a pod that will run that same command that we did before, where we're injecting user info into our attempt to call the Who Am I service. Oh, wait a minute. Did I do this right? I might not have done this right. Oh, code doesn't write properly. Mark doesn't know how to read. Let's try this again. Control, delete, pod. What's it called? Control, get pods. Kube control, delete, pod, curl. All right, let's try this again. There we go. So we can see here, there's a lot going on. This stuff we could all ignore. This is the important part. Access denied. Because we were trying to hit our API outside of the mesh, but from inside the cluster. So that kept us from being able to actually bypass authentication. Let's see here. Oh, yeah. Well, sorry, if you don't show up on time, it's kind of like you show up to the show, you get seated at intermission. Okay, Scott?
I was slacking today, to Boris. Yeah, there's no doubt. I actually had my real job.
Boo.
Had something. Yeah, I know. Really, the one that pays the bills. That's a little bit less fun than coming here. Still fun. Don't get me wrong, but.
I see you're querying a security group, but where's the rest of the connection to AD? So the previous chapter when we deployed Open Unison, we deployed a Active Directory into the cluster as well. So there's an Apache directory service that has an Active Directory schema. And so that's where all that directory data is coming from. So when you run this in your own lab, you don't have to worry about having Active Directory running. It's all inside your cluster.
And I think it's still there, right, Mark? In the Unison chapter, I covered how to add like users and explaining a little bit about Apache DS, just so people could understand what to do more with it, because it was a little bit confusing.
Yeah, it's
nice.
It's not it's not meant to be a general purpose system, but for our purposes, so that everything's self-contained, it works nicely. So we had just launched the pod, and we showed that if you're not in the mesh and you're trying to access it, you can't bully your way into the system. So here's our next question: how do we do more complex authorizations? And what's complicated about authorizations in particular is that authorizations are typically a business process, right? The people who own authorizations are the people who own the application. And so over the years, there have been many attempts to try to externalize authorization the way we have with authentication. Authentication AD, nowadays with some kind of identity provider, whether it's Entra, Okta, whatever. But the point is that we've centralized it, right? Applications should not be right. We know that applications should not have their own. This is a lot harder with authorization. Authorization are business processes. It's not just a matter of the mechanical aspect of authentication. And so, especially in the last couple of years, there's been a big move to provide authorization services. And so earlier in the book, we covered OPA, right? We used OPA for admission controllers to be able to control which pods can get started, mutators, all that kind of stuff. Well, OPA is a general purpose authorization language or system. And so you can use OPA to authorize Istio decisions that are more complex than member of a group. And so, like the example I use here is, hey Scott, do you have the right microphone on? 'Cause I'm getting a lot of feedback from you.
Oh, I might be on the wrong one. Yeah, let me.
That's better. Um, so, so classic authorization. One of the classic authorization examples is something called separations of duties, where if you're a member of one thing, you can't do something. If you're all, uh, uh, you can't be a member of two things at once. So, as an example, most businesses, the person who writes the check isn't the same person who signs the check. Now, kids, if you don't know what a check is, ask your parents. But so when you write a check, the person who says how much money goes on the check is different than the person who signs it, so that it can go out the door. And the reason for that is really simple, right? You want to have some kind of check, not paper check, but a process check to make sure that you that's an authorized payment, right? Um, and so you can't really do that with static groups, right? Because if you're the member of one group, but you're not a member of the other group, or you're a member of both groups, maybe there are certain situations, but you want to make sure you're not doing both at the same time. And so that's where you can use OPA with Istio to be able um, to do these more complex authorizations, where you can tell Istio, hey, give me a webhook that I can call, and I'll go ahead and call that with the payload. So I'm on page 546, and I will tell you, I am not a huge fan of externalizing authorization at this level. I find that it usually gives you diminishing returns, but I'm kind of in the minority here, so that's one of the reasons why I included this in the book. There are a lot of different authorization engines out there. I don't necessarily have a problem against authorization engines so much as trying to centralize it at the Istio layer. I still think it's better done within your application, even if you decide to call out to an external system. Because if something breaks, you don't want to go blaming the Kubernetes people. Or I don't know, maybe you want to go blame the Kubernetes people. I mean, what do you think about that, Scott?
I get blamed for everything. You burn your toast in the
Yeah,
morning, it's usually my fault. So,
exactly. Um, I mentioned a few different projects in here. We do OPA because we did OPA back in the admission controllers, and we're staying consistent. There are a lot of projects right now that do this. Cedar is one that came out from Amazon that has been getting a lot of fanfare lately. Very fast. It's known for being mathematically provable, right? So like you can mathematically prove that the policy works, which is really interesting. Um, OpenFGA is, I believe, from Okta, maybe Auth0 and Okta, where it uses graph-based relationships to determine how we're authorized. So instead of saying, well, are you a member of a group? It's, do you have this relationship in place? And then Topaz, which is more of an authorization, is a authorization engine, combines OPA and Zanzibar. Zanzibar is another graph-based authorization system, but using the Rego policy engine to give you a combined approach there. Have I used Caverno to assign match policy instead of upon case? I have not done a lot with Caverno. I know it's extremely popular. It got its claim to fame because it was purpose built for Kubernetes. OPA is not purpose built for Kubernetes. Was just there, like it was good timing. We didn't originally include Caverno because you could only use Caverno for Kubernetes. You could not use Caverno for this use case. That is, I believe, not true anymore. So maybe in the fourth edition, we'll relook at maybe doing Caverno. But yeah, Another great system. So the first thing we need to do is we need to create a authorization policy, right? We need to create a policy that's going to yeah, let us do what we want to do. So here's our policy. Hold on a second here. My day job might be getting in the way. I'll worry about that later. So here's the policy, and there's not a lot going on here really. We're validating some headers, and then really the main thing is, am I in the right one? Am I in the test or am I? Yeah, I'm in the right one. Verify the headers, make sure there are groups, make sure the user is an admin. Okay, here we go. So this is where our rubber hits the road. We're getting the headers, we're making sure there are groups, we're making sure that a user is a member of the cluster admin group, but not also a member of group 2. So that's kind of our our check writers versus check signers. So it's a little bit more complex logic. Now, instead of deploying this into the generic Istio, right? Like we're not going to have a generic OPA that does all of these authorization calls for a couple of reasons. One, you get into issues with multi-tenancy where you don't want the policies to be overwriting themselves. There is a OPA system called, or there is a OPA. I'm trying to. It's an OPA service. It was part of the commercial offering from Styra. Very recently, like within the last few weeks, Styra doesn't really exist anymore. The developers got acqui-hired by Apple to continue working on OPA because Apple's well known as an app OPA user. But the commercial offerings have all been open source. So this might now be an open source offering. Maybe we'll look at it next time. But generic OPA doesn't really work well in a multi-tenant environment. So we run OPA as a sidecar on our service to do the authorization, which means we got to get the sidecar in there. So we created a admission controller with OPA that injects the sidecar into our deployment. There's a lot going on there. So we've got our authorization rule. And so let's see, have I actually run anything yet? Where do we actually go? Okay, so we're going to go to our policy. Now, I was messing with this all morning, so pray to the demo gods that this actually works, because this was not working easily this morning. So, all right, so we're going to go to chapter 17. And we're going to go to, where are we going to go? We're going to go to, I'm on page 548. We're going to OPA. All right, we're going to run deploy OPA Istio. So first thing that's happening is, for some reason, that's broken on my system. Got to install the YQ utility because what we were actually doing, you can see while this is running, well, nothing failed. That's a good sign. We create our OPA Istio namespace. This is the OPA that is doing the mutating webhook controller that is injecting OPA into our service so that we don't have to manually add it to our deployment. And then we updated our Istio configuration so that OPA is a possible authorization engine. And then we labeled our Istio Hello World application so that's in the make sure that's in the inside the mesh. And then finally, we restart our pod. So I'm going to go ahead and actually log into our pod. or I'm going to log in here because it's a little bit easier to show this off. So if I go to the dashboard, and if I go to Istio dash hello world, so everything's green. That's a good sign. I'm going to make this a little bit bigger. So we're going to see that we actually have 3 containers running inside of our pod. We've got Python, so that's our actual service that's doing the work. We've got our Istio proxy, and we have our sidecar, so our OPA sidecar. Now, one of the reasons that I was going nuts this morning trying to get this working, and this is now fixed in the repository. When we first wrote this, this was before Riga or OPA 1.0 came out. And so we need to make sure to maintain version 0 compatibility. So we did this way back in the OPA chapters. This is now updated here as well in the main repository in this chapter. So we got our pods running. So now in theory, we should be able to do some testing. So let's go ahead and try logging in as M. Mosley. So now I didn't want to click on that link. Stupid browser. Where'd you guys go? Okay, here. So the first thing I'm going to do is I'm going to access this as M. Mosley. And we're going to get a 403 forbidden because M. Mosley is a member of both groups, member of both Kate's admin and Kube Control, or Kate's admin and Group 2. So what am I doing here? I want to come back over here. Let's come to my scratch pad. And let's clean this up. So K2U apps, that's going to be 53. Going to be 53. So this is the same service we've been calling the whole time. It's just now we've added this additional authorization layer. So we should get a 403. Yep, 403 forbidden, refused by Istio. Now, something too important here. We got a 403, but we didn't get that RBAC error we saw in the last set of exercises. That's because it's not Istio that's denying us because of an authorization policy directly. It's because OPA is denying access to the request. It's a little bit different of a response. So we're going to do the same thing, except this time, and I'm on page 549. We're going to make one minor change here. So we're going to run as pipeline service account. Pipeline service account. Oops. And the reason why we're going to run this as pipeline service account is pipeline service account is a member of just one of those groups, the Kate's admin group. They're not a member of group 2. So if all goes well, this should work. And it did. So if I do JQ-R dot headers, right? So it worked. The reason why that worked was because the user was a member of just one group, but not both. So we were able to hit OPA. If we take a look here, come back here, let's go to the logs. And if we go to OPA Istio, we'll see here there's a whole bunch of stuff going through here. Let's see if I can find one that was successful. So like here was the input, hello world. Does it have the, yeah, that looks like it's okay. I'm looking for a failed, like sent response, 200. All right, let's see if I can do it this way. So let's do it. So that'll fail. That failed. Come here. All right. So see if I can find authorization bearer. Trying to see if I can find like a decision in here. There's the decision log. All right, result. Here it is. It's kind of hard to see, but result full. So that's buried inside of the. Yeah, I get we do JSON logs these days because it's easier for the seams, but it's really annoying when you're trying to debug things. But you can see that it's OPA that's failing the request. All right, so we are at the top of the hour. We haven't yet covered identity, service-to-service identity. I think I maybe want to do that next. I know Scott, you're out next week, right? You're muted.
Yes, I am. Yeah, I didn't want any of the background noise. Yep. I'm back the week after, though.
So why don't I cover service-to-service identity? We'll do one last, because that one's a really complex topic. I want to make sure to give it its due.
Makes sense.
So we won't have
close out
Scott.
the chapter.
Yeah, and we won't have Scott showing up late trying to see how long it takes Mark to figure out. But we'll go through this then, and we'll wrap up the chapter then, and then it'll be home stretch and building out a service, and we'll do that once Scott gets back. That's going to be like a 3 or 4 week easy.
Oh yeah, that's big.
It's 2 chapters, but we're going to be deploying a whole lot of stuff, so we're going to want to take our time, really go through stuff carefully. So we'll go ahead and do next week. It might be a little shorter next week because it's a little smaller of a topic. But knowing how I like to ramble, maybe not. Anything you want to kind of add, Scott? I know I monopolized this session.
No. Well, I came in with only 25 minutes left, so no, great discussion, right? I know it's a complex topic.
Yeah. So thanks everybody for joining us. Again, this chapter there is an errata in the it's checked in errata.md. So if the stuff's not working for you, go ahead and check there. See if I gave you some fixed commands, and we'll wrap things up with Istio next week with service authentication. Everybody, thank you very much. Scott, thanks so much for joining, and have a great rest of your day.
Yeah, thanks everybody.